How would you add, subtract, multiply, or divide in scientific notation? And what if the digits change up? What if you end up with one digit too large or one digit too small? Then how would you renormalize it? Well, that's what we're going to be going over in today's video, which regards arithmetic in scientific notation, and exactly how to navigate it if it goes out of hand and it becomes standard notation instead of scientific. So first, let's go over multiplication, okay? Multiplication is fairly straightforward in scientific notation. You have a times 10 to the m, and you have b times 10 to the n. If you multiply these two numbers, you multiply a times b, right? And then you multiply 10 to the m times 10 to the n. And if you remember your exponent rules, you know that 10 to the m times 10 to the n becomes 10 to the m plus n. So this entire expression evaluates to a times b times 10 to the m plus n. Okay? So if you wanted to go over an example, let me go over this example over here. 3 times 10 to the 4 times 2 times 10 to the 6. First, I would multiply the 3 by the 2, which gives me 6 times. Then, I would multiply the 10 to the 4 times 10 to the 6. So it becomes 10 to the 4 plus 6, or 6 times 10 to the 10. Now, but there are scenarios where the multiplication between these two numbers doesn't fit our constraint. What does that mean? If you look over here, 5 times 10 to the 3 times 4 times 10 to the 5. When you multiply 5 and 4, you get 20, right? And when you multiply 10 to the 3rd and 10 to the 5th, you get 10 to the 5 plus 3, or 10 to the 8. But notice how this doesn't fulfill standard notation, scientific notation, right? 20 times 10 to the 8. This one doesn't fall under our constraints of 1 is lesser than or equal to a, and that a is lesser than 10, right? That's what we need here. Those are your constraints. So, but 20 is greater than 10. So what do? We renormalize it. How do we do that? Well, like I said, right? We shift the decimal again. So 20 times 10 to the 8th. If you want to get this to be by itself, what do? We divide by 10 here, which means we have to multiply by 10 here. So it becomes 2.0 times 10 to the 9. Okay? Or you could just rewrite it like this, 2 times 10 to the 1. Right? And then 2 times 10 to the 1 times 10 to the 8 becomes 2 times 10 to the 9. Okay? Just make sure that whatever you rewrite it as, this falls into scientific notation, this a value. All right? Now let me show you how you do it with division. When you're dividing the coefficients, you have to do something a tad bit different. You divide a divided by b, like regular, right? So if you have a times 10 to the m divided by b times 10 to the n, you do a divided by b times 10 to the m divided by 10 to the n, which is 10 to the m minus n. Now, this one is a bit more direct, right? So a divided by 2 becomes 4. And then 10 to the 7 divided by 10 to the 3rd becomes times 10 to the 4, which is straightforward. Over here, though, the exponent can go negative. What do I mean by that? Well, when we divide 9 divided by 3, we get our first number, or the a coefficient, which is 3, times what? 10 to the 5th divided by 10 to the 8th. So if you use our exponent rules, we know that's 10 to the 5th minus 8. So that becomes 3 times 10 to the negative 3, which makes sense, right? This is a larger number. So you're going to end up with a decimal, and 10 to the negative 3 is basically 3 divided by 1,000. So this does give you a decimal. Okay? And remember, if you have any units, you want to put in those units. So let's try these problems, right? Give it a try, pause the video and give it a try, and then I'll go over them with you. Okay, so now let's go over them. First, this problem. This one is fairly straightforward. Multiply the a times the b, you get 8, and then the 10 to the m times 10 to the n, which becomes 10 to the m plus n, or in this case, 3 plus 5. So 10 to the 8. Okay, pretty straightforward. Over here, you divide 9 divided by 3 times 10 to the 9 minus 4, or 3 times 10 to the 5. But over here, you need to renormalize. What do I mean by renormalizing? Well, it's the more fancy expression for what we just did right now, right? You just see whether it, breaks off from scientific notation after you multiply or divide. And then what do? You change it to make it represent scientific notation again. So first over here, you multiply 6 times 5, right? Becomes 30. Then 10 to the negative 2 times 10 to the 7 becomes 10 to the negative 2 plus 7, or 10 to the 5. But now we can see how 30 and 10 to the 5, 30 is not under this constraint, lesser than 10 and greater than 1, or greater than equal to 1. So what do? I would do 3.0 times 10 to the 1, right? Times 10 to the 5 becomes 3.0 times 10 to the 6, renormalized. So this time you just, have to convert it into scientific notation. You need to write it like this. You can divide by 10, and then you can multiply by 10 here, or you can just, visualize it. So 30 is over here. If you shift the decimal point over here to become 3.0, then over here this 5 has to become a 6. Okay? You can look at my video in standard scientific notation if you want to go in more depth about how to do that. Okay. Now over here, this is a bit more complicated as well. It becomes 4 divided by 8 times 10 to the 3 minus 6. 4 divided by 8 is 0.5 times 10 to the what? Negative 3. So now what do? Well, over here, how do I get to represent this in terms of 5? Because that's what I want, right? 5, not 0.5. This also violates our constraints of lesser than equal to 1 and lesser than 10. Oh, sorry, greater than equal to 1 and lesser than 10. So I do 5 times 10 to the negative 1 times 10 to the negative 3. And it becomes 5 times 10 to the negative 4. Because negative 1 and negative 3 would add, right? When you multiply two of the same base, you add the exponents. So negative 1 plus negative 3 is negative 4. All right. That's it for this video. And next video, we'll be going over reading scientific notation from data. If you want to look at that one, then make sure to give me a like or subscribe, and then you can check my channel for the next video. Also, be sure to check out oddslearning.com for more practice problems on these, and PDFs and videos that could help you out on your journey. All right, that's it, guys.